Today, I want to talk about your Project 1. The objective about your Project 1 is that I want you guys to implement a classification algorithm in real coding. So we have discussed about 3 different classifications at this moment. We talk about decision tree, k-nearest neighbor, naive Bayes. So basically, I want you guys to choose one of the classification algorithm that interests your team most and then really implement that. And I also want you to implement that on a real world data so that you can have some real practice. And for this project, I want to make it like a research environment so that this description talks about the first part of the project. After we have done the things that we have discussed over here, we then will have a meeting and then we will discuss about the next step. So we see these figures many times in our class already. The classification obviously is going to be the data mining part of this throughout the whole knowledge discovery process. The thing is that the data I'm providing you is basically went through a big steps already, so that what the data you get, a real world data, is already what we call a task relevant data. Therefore, in this video, not only I want you guys to understand what you need to do regarding to the classification algorithms in data mining, I want you to get more familiar with the task relevant data, including how does the data that has been processed so that the data set that you're going to use in this project is being cleaned as well as ready to use. So you will be provided 2 data sets. One is what we call a training data set. The other one is called a testing data set. And of course, the classification algorithm that you're going to build will need to train on the training data set and then make your predictions on the testing data set. Later in the slide, we will take a look of the data itself. So since the data is the data that I am using in my research, so I need to let you guys know a little bit about my research area. The area is what we call the wine informatics. So wine was considered as a luxury in old days. However, you know that today it is much more affordable to public. The quality of the wine is usually assured by the wine certifications, which is generally assessed by 2 different things. One is what we call the physical chemical data. The other one is called the sensory tests. For the chemical analysis, this is most currently research in wine works on. So you can see that these kind of things are numbers. How many days for the fermentation? What is the percentage of new French oak has been used? What is the barrel aging, pH level, alcohol level, etc. Obviously, this kind of thing is much easier to be implemented because try to think as in computer's point of view. Those are the numbers, and then processing the numbers are much more easy than processing some other things in contrast with what we call a sensory analysis that we're going to look pretty soon. That's why most of the data that's available is capturing this chemical analysis. However, on the other side, the sensory analysis is like a description about the wine, what it drinks, what it tastes like. So that requires a lot of trainings and requires some experts that you trust so that you will be able to read their descriptions and then make the judgments about whether or not the wine is good or not. So this example I provided you guys is the same wine, Coastal Brown Pinot Noir from Sonoma Coast in 2009. And then the chemical analysis is like this one. The sensory analysis is like this one. So it's indicating it's ripe and deeply flavored, concentrated, and well-structured. Full body red offers a complex mix of black cherry, wild berry, and raspberry fruits, etc. One thing you can understand is that the chemical analysis is probably more useful to wine makers So the role is going to be different in the target. The sensory analysis is probably more interesting to the wine consumers. So they are targeting on different areas. And that's why the two different kind of data has different meanings to different actors in the research. In Wine Spectator, in case that you have not noticed, this wine over here has the descriptions, and then it will also provided a grade, overall grade. The wine that you see is actually receiving points of 96. So this is down by what we call a Wine Spectator, being considered as the experts that use to test the wines and write the reviews and also give the verdict, a score, to summarize the results of that. So they basically review 16,000 wines per year. Currently, there's more than 300,000 wine reviews in the database. At this stage, it's probably close to 400,000. So you can see that the data is there in the database, and that feeds the idea about data mining, because we want to find some interesting information from large amount of data. Compare with this wine review data set, if we are looking at the chemical analysis, physical chemical analysis, the data set usually contains about like 100 wines. Mostly less than 200 wines only. So it's kind of much smaller in the size. And therefore, personally, I think it is very interesting to use data mining, finding useful informations through the large amount of data set. So that for each reviewed wine, they will give a 100-point scale to reflect the quality of the wine. And basically, you can see that if a wine received between 95 to 100, it's a classic wine. Only very few percentage, less than 3% of the wine receiving this category. 90 to 94 is indicating that that wine is outstanding. Most of the wine, as long as they receive what we call 90 plus wines, they are actually very good in the category. When that's happening, they actually use advertisement to indicating that their wine receiving higher than 90 points from what we call a Wine Spectator. So that is a very important recognition of the wine. And then 85 to 89 considers very good, 80 to 84 considers good wines. So that in this category, most of the time, if the wine is 85 to 89 and the price is actually pretty affordable, so something like $10, $15, then that would be recommended as the smart buy over the best buy, etc. So this is like the background of the data as well as the scoring systems. So now let's take a look of this one. So saying that we are looking into another example, Dow's Vintage Report 2011, it received a perfect score, 100 points. And when we are trying to read the reviews, one thing you need to understand is that for humans, when we read these reviews, we may pick up some important keywords. So for example, when we look into that, we may be interested in those words that are in bold, because those are some important descriptions about the wine. Now, the question is, how do we make computer to read this review? So this is what we call a natural language processing part of the problem. More importantly, when we read those keywords, for example, powerful, refined, luscious, dark plum, kirsch cases, uncutus, and long grip, long finish, full finish, Asian spice, etc. Many of those are considered as like real fruit, the one that in red color, or the real food that can be tested. Some yellow part of the word are indicating what is the structure of the wine. And then when we go to the blue words, those are the kind of the words that try to describe the wine in an adjective form. So there's actually different kind of structures to read into the reviews over here. And you need to understand this. Although the data set that we are looking at right now is about a wine, this similar structure can be applied in different things such as tea, coffee, liquors, And it can also be applied in many other different kind of things in the review formats, such as hotel review, such as Amazon product reviews. So this is giving you an idea of how can we process the real languages into a computer recognizable data set. So as I mentioned, there are 3 different kind of categories, and each one of them have their meanings. They're describing different things, and that's why what we did is that we create something called a computational wine wheel to process that. So if we are able to process the wine reviews, the next question is how do we mine unique patterns and information to benefit society, including wine producers, wine distributors, and wine consumers. So those are the interesting things, saying that we are able to parse those words out automatically, and then computer can really get all the important keywords regarding to the 300, 400,000 of wines. When we can do that, what can we do? So basically, there's many different things that we can do. First of all, what makes wine achieve a 90+ rating? So by using data mining techniques, probably more useful in this category or this topic is going to be the classification, which is something that we are going to do in this project basically. So this is like a first question. What are the shared similarities among groups of wine, and what is the food suggested pairing? So obviously the second one is more like a clustering problem. What characteristics different between the wine, Bordeaux, France, and Napa, United States? So this is the kind of problems can be tackled by classification as well as association rules. And what is the weather impact on the wine growing process? I actually also have some paper regarding to this topic in using, I believe, classification. So a lot of different things can be done if we are able to automatically retrieve the wine attributes, and so that we can work on many different research topics. In fact, I have been writing several papers regarding to this area. So what we need to do, of course, is talk about a computational wine wheel, which is the tool to automatically retrieve the data, the keywords out from the reviews. So you can see this is also considered as the data preprocessing part. So Wine Spectator selects top 100 wines based on quality, value, availability, and X factor, which is the excitement to them. And what we did is that we collect past 10 years top 100 wines, and then we handpick all of the important keywords out of that to form what we call a dictionary style, and that's what we call the computational wine wheel 2.0, because there was a first version that used only 100 wines. When looking at our finished list, we noticed that many cases or group attributes were really actually on the same thing. So basically, if you see a fresh cut apple in the review, ripe apple and apple, they are actually apple. However, if they are indicating it's a green apple, it's not really an apple anymore. The flavor between apple and green apple are different, and that's why they will be put into different categories. And therefore, the computational wine wheel is going to give you an example like this way. What the computational wine wheel trying to do is that we collect all of the keywords and we really look into all of them one by one. We form some category. So there's a fruit category, overall category. If you are interested, we can talk a little bit more about that. There's a total of 13 categories. Each category have their subcategories. And then it's the real word that appeared in those 1,000 wines that we collect for the 10 years of the top 100 wines. If we try to match, we use these original words to map with all of the reviews. If we find a mapped word, then we use what we call a normalized word to represent that. Because remember, we talk about fresh apple and apple, they are actually the same thing. So we don't want to separate them. If they have a match of those words, we will use what we call a normalized word to indicating they do have this flavor. Because of that, you see that the data that you will see is actually in the binary format. If they have the flavor, that's a 1. If they don't have that flavor, that's a 0. In this example, you can see that if the words appeared inside of the review have firm tannings or chewy tannings, then they will all map into tannings high as the normalized word over there. And that is how we would be able to use the computational wine wheel to find the attributes presenting the wine that we are interested in. One more detail that I want to discuss is that when we try to apply the computational wine wheel, we basically write a loop to go through all the original words, but we start with combination words, the bigger words first. So that in this case, we will start mapping with white berry, firm tanning, chewy tanning, light tanning with the reviews first. Once we find those words, we would be able to mark it with the normalized words and then take them out so that you can see the wild berry will catch the wild berry over here, so that when berry comes in, wild berry is already caught. So we will not to put the berry into this case, so that we would start with the bigger words and then goes to the one word. And you can see that when we apply this simplified computational wine wheel, the real computational wheel is much bigger than this one. We will be able to capture the 3 attributes from this review. And obviously, you can see that the bigger computational wine wheel, the more accurately we will be able to capture the words from the reviews. So we will be able to represent this wine with the 3 ones on the 3 attributes that we have seen over here. Therefore, let us take a look of the given data set in your project in terms of the training data set and testing data set. So if we take a look of the training data set, you see that the one I provided you guys is the one with about 200 wines. So you can see that there's for your training data set, I provide you 200 wines over there. For the first column, it's talking about the name of the wine, so that's obviously an identifier. The very first attribute that provided over here is the label. So based on the grade, I actually indicating that if they are 90 plus, indicating they are very good wines, classic or outstandings, then they receive a 1 over here. So obviously this is the label that we have seen. If they are not as high as 90 scores, they get a 0 over here. So this is your training label. And therefore, you will use this as the label in your classification program. Then all of these are the attributes. There's probably close to 1,000 attributes over here. If they have that flavor, then you have a 1. If they don't, you get a 0 over there. So this is going to be your training data set. What you need to do is that you need to write your classification algorithm based on these attributes, find the rules to map with the label over here. After that, you will use that model to make the predictions for the testing data set you see over here. So in your testing data set, I provided you 20 testing data sets. The label, of course, is given in here already, so we know the results. And so what you need to do is that you need to use your classification model, reading all of these attributes. Based on the model, you make the prediction for the wine to be a 90 plus or 90 minus wine. And we will be able to compare that prediction result with the real results so that we would understand how good the model is. So this is like a process of the evaluation in your program. If you have any questions, please come to the class online support, and then we can make sure you understand everything. Therefore, here is the requirements for your project. Part 1, the very first part is that please implement one of the classification algorithms introduced in the class. So you can choose from decision tree, naive Bayes, or k-nearest neighbor. Of course, decision tree, naive Bayes are the two algorithms that really build a model or do some pre-calculations before we make the prediction. Of course, if you choose k-nearest neighbor, it's a lazy learner algorithm, then you would need to use the training model to compare the distances with the testing data set and then make your predictions. So these are the things that you need to choose among your team. I'm not require you to do any specific language. You can choose whatever languages that you want. However, you need to write your own code. In other words, you cannot just use Python and call a Python library for, say, k-nearest neighbor and then say that you have done the work. This is not the whole purpose. The whole purpose is that I really want you guys to implement an algorithm based on your understanding. And remember, we also have the part 2 to improve the results that we have get, or to do more things based on that. And therefore, you need to write your own code. Perform the prediction of whether a wine can achieve 90 plus based on the sensory reviews. Apply the chosen algorithm on the training data set and then predict the label for the testing data set given in the project. So that's the first part. The second part is this. Compare the predicted result with the true label in the testing data set. For the testing data set, since you already know the results, I mean, you have their true label. So you need to compare your predict label with the true label to understand how good that you have made. In other words, saying that you see the first 10 one is 90 plus, for the next 10 one is 90 minus, and when in your prediction, you predict every single 90 plus one correctly. So all of these ones you predict is 1, 1, 1, 1, 1 for the year, and then you missed one, just one of the 90 minus 1. So you predict this first one as a 1 and everything else as 0. So out of 20 ones, you actually correctly predicted 19 of them, so that you will be able to calculate what we call the prediction accuracy, indicating how good that your prediction is going to be. And so that's something that you need to be done in the evaluation purpose. So compare the predicted result with the true label in the testing data set, calculate the prediction accuracy, and that's something that we will be able to look into. The last part of this project is that I want you to implement SVM using SVM Lite on the training data set and make predictions on the testing data set. We will talk about SVM in the next class so that you have something to compare with. And for SVM, I'm not asking you to write your own code because it's a little bit too complicated. So in the class, we will talk about a software package called SVM Lite. You just need to learn how to use it and then apply the training data set over here, and then SVM Lite will train a model for you, and then you feed in the testing data set. So you have multiple team members. Each one can be responsible for different things. So how would you arrange that is something that you guys need to think about. After that is done, I also want you to calculate the prediction accuracy and compare with the part 2 so that you can have some comparisons to see the SVM versus the implementation that you have done. Are they matching with each other or not? So these are the 3 things you have to do before the due date. So the due date is going to be given in the Blackboard. Those are the 3 things that you need to be done in this Project 1 Part 1. I will arrange online meetings using online support link with each team. I will take a look of your program and the prediction results so that we can discuss if you've done things correctly, how is SVM work versus the results that you guys have achieved. We will discuss about your result and have one more step of the programming improvement discussion as follow-up projects, which will do 1 week after the meeting. So please prepare your testing data set in the form of this. Remember that we have like 20 testing data sets. You already have the real grades, so that you put that on the leftmost column. And then you can also output your predicted grade so that we can clearly see for all those 20 ones, which one is predicted correctly, which one is not predicted correctly. So this is again some formats that we can have. You are encouraged to send team members to join the online support during the week next week, as well as like during the week between today and the due day. I want to have some conversations with you, make sure you guys are on the right track. And like I said, you have multiple team members. You can arrange those kind of things smartly so that we can have the best performance out of it. So these are the requirements that I have prepared for you guys. Again, if you have any questions, you are welcome to join the online support, and then I can clarify any questions that you may have.